Yeah, so we have seen up to RNN part, right? The theoretical concept of the RNN and how does that going to help us to understand with respect to the neural network concept. So let's go and check out some IPython notebook so that we can get some idea with respect to some different data set what we have. So yeah, whenever you need to play around with the TensorFlow, you can directly import like this. So this is very useful whenever you want to play around with the Keras and also the TensorFlow. This eventually used for any kind of the deep learning mechanisms to build top on it, whatever the data sets you consist of. And something called as a transfer learning also. We are going to be discussed maybe the upcoming classes. So I'm just imported TensorFlow with some of the layers we are going to be handed out like a dense layers and somehow the RNN layer and also some different layers, fully connected layer. We can use maybe in the CNN part further to understand different layers are going to be do in terms of any kind of the pre-trained mechanisms model what we had, and along with the whatever the standard libraries we have used in the classical ML with recording the loading and also the calculations of the NumPy and somehow plotting of the libraries like matplotlib and cbun. So this is somewhat slightly interesting data set, I can say. We are going to be extract the data set from the different sine waves. So I have a data set to represent by using the sine wave, and also I have it one data set with respect to sine wave. I will going to use with respect to the sine wave data set. I've also extracted with respect to some of the random values what we had. And according to this, I have another data set which consists of the squared nature. So you can say this is a squared nature data set I had and something called as a triangle data set. So I just extract it by using these triangle and the squared and also the sine wave kind of the thing, so that we can play around with. This is a multi-class classification. Obviously, we have three different classes we are going to be together. And on top of it, we are going to be concatenated with respect to one data frame. So I will extract these three data frames according to the random values what are going to be generated. I will generate by using the whatever the data frame we are going to be had. And then I will play around with this data set corresponding to the RNN mechanisms what we learned. It's going to preserve some kind of the sequence information according to whatever the data frame. Then we can classify by using this. We can run maybe the some heap hops, 100 heap hops or 10 heap hops according to our functionalities. What are the different hidden layers we are going to be constructed. So let's go and play around with this data sets. So you can see here we are randomly generating some different range of the points corresponding to the sine wave, just using the sine wave information from the NumPy library itself. This is how it's going to be looks like with corresponding to starts with 0 and ends with some point. Similarly, the square nature, if you're aware about the NumPy, what are the different functionalities we have with consider of the size, square wave, and also the you can say sine wave signals, so that you will be much familiar with this to get the random initialization of the corresponding data set we are going to be extracted. So I'm just storing in the date square and also the storing in the date sine, and corresponding to the triangle signal also I'm just storing into the data triangle with corresponding to all the different data points we had extracted between these kind of the distance, you can say. So I'm just converting that into the data set so that we can play around with this instead of directly taking from the Kaggle itself. So every time we eventually taking from the Kaggle, what happens if we take from the Kaggle, it's already a structured data set, right? So if you have already a structured data, it may not be works well with corresponding to whatever you have learning on top of the models. So eventually what happens in the real world, obviously you're going to be take as a raw data set or metadata set. It will be works whenever you do somehow the structure like Kaggle data sets what we have. So let's play around this so that we'll get some idea. Eventually we're going to be understood how does RNN also will going to help us understanding. So this is just a simple function to convert, you can say, from whatever the signals, different signal data frame what we had. So I'm just iterating over to append some of the values with respect to that, so that it will create the data frame like that. So I'm just calling the function with respect to the sine wave and also the squared and also the triangle wave to convert the different data sets. So just taking exponential operations with respect to sine and also the squared and also the triangle wave and concatenated together, so that will create the data frame with respect to the x and also the y values what we had. So just extract it So in this case, what will happen? Sine wave represented as a 0, and square wave represented as a 1, and triangle wave represented as a 2. For just for understanding, so that we can also play around with this in the classification. How does it going to be helpful in the prediction wise after completion of your model building? Yeah, you can see here, we just extracted that. Yeah, we just extracted that, and we just split it into our train and test data set according to the X train, X test, Y train, and also the Y train. Similarly, whatever we done until this step, this is just a data retrieval, you can say. So we all run this so much in the classical ML also, so many other different projects also we have implemented to this step. So after this step, what will happen if you do any kind of the machine learning, or you can say deep learning kind of the models, you can try to encounter with some hidden layers according to the whatever the neural network you're going to be applied. Currently we are applying recurrent neural networks. It's going to be tried according to that whatever we learned yesterday theoretical nature, so that we can also pass some of the input layer according to this. So currently you can see we just passing the 64 units, or I mean input dimensionality of the 64 units with respect to the RNN, and the shape wise we just showcasing as none corresponding to this. This is a very simple RNN, I can say. You can also pass different units to understand this data set. These are all the hidden layers with showcasing with the dense layer. So dense layer is simple layer. Okay, so you can understand as of now is a simple layer to represent with respect to the inputs and also the activation function to showcase. So currently we had four hidden layers. You can see you can also pass maybe two or other addition of the hidden layers with corresponding to the dense or maybe the other fully connected layer. So that's also works out. So we have so many layers, different layers we are going to be learn maybe in the CNN part, so that you will get to understand where to use, where not to use these layers. So this is a four hidden layer unit with corresponding to the simple RNN architecture. And at the end, obviously, we are going to be used as softmax because it is a bind, it is a classification task. And you can see the compile after this is just a